Hello and welcome back to Purus Tech Java tutorials. In this session, we are going to cover about the recursive method and the recursion. So recursion is the process where the method call itself again and again, right? Whether it is direct or indirect call. So that is called the recursion process. And the method which calls itself, right? Using the recursion algorithm is called the recursive method. So let's jump into our IntelliJ IDEA. This is a simple example which finds out the factorial of a number. So here I have the main method, and here I have one more method which is the get factorial, and it takes an integer argument which is passed from the main method. So basically I want to find the factorial of 5. So here 5 is passed, and here one condition is getting checked where it is less than equal to 1 or not. And then there is one more line which is called the return n into factorial of n minus 1. Now let's go and just understand why this logic is coming into picture in case of getting the factorial using the recursion. So factorial is nothing but the number, and you need to decrement the number one by one until you reach 1, and you need to find the multiplication of all this number. So factorial of 5 equal to 5 into 4 into 3, likewise it will go up to 1. Like that, let's say factorial of 10, then you need to say that factorial of 10 is 10 into 9 into 8 into 7, and then it will decrease up to 1, and you need to find all the multiplication of these numbers. So I can write this 5 into 4 into 3 into 1 as like this: 5 into factorial of 4. This particular thing, right, within the parenthesis, this I can write as factorial of 4. Now this factorial of 4, what is factorial of 4? I just separated out here, and I wrote 4 into 3 into 2 into 1, which is nothing but your 4 into factorial of 3. So likewise it will go up to 2 into 1, and then 2 into factorial of 1. So factorial of 1 is always 1, and we don't need to evaluate further, right? So what is the base condition? Base condition is when we reach 1, we don't need to evaluate. So here, as you can see, factorial of 5 is utilizing factorial of 4, and then this factorial of 4 is utilizing factorial of 3. Similarly, it calls itself. So the function or method is calling itself to evaluate to the final value, and this process is called the recursion. And the method which I have used, that is fact here instead, like in the program, this get factorial is the recursive method. And the same condition I have given here, which I have shown in the Excel sheet, right? When the base condition it receives 1, then it will return. It won't evaluate further, and it will return 1. So here let's say first we'll put 5, then it will check 5 is less than equal to 1 or not. Okay, this condition is not satisfying, so it will come here, return n into n is 5, so 5 into get factorial of 4. So we don't need to return here until and unless this methods evaluates its value. So let's just go to the Excel sheet and see how the recursive call happens here. See here, this is the full logic of recursion method, which is finding the factorial. So for the first time, it checks 5 is less than equal to 1 or not. So it is false, so it comes here, and then it returns 5 into get factorial of 5 minus 1. So we need to evaluate before returning this particular value. So evaluation, again it calls the same method, and same method logic just replaces with number 4 here like this. and we say return 4 into get factorial of 4 minus 1, which is nothing but get factorial of 3. And the same logic continues further, 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 and it reach up to 1. So when it reaches the get factorial of 1, what it does? It returns 1. So where it will return? It will return to the callee. So who called? This method called. So here, this method can be rewritten like this expression, return 2 into 1, which is 2. So from here, the callee method returns one value, that is 2 into 1 equal 2 here. So this is nothing but 3 into 2. Again, this returns back to the callee and it becomes 4 into 6. Similarly, it will go up to one level up, and here it will come as 5 into 24, which is nothing but your 120. Now let's go back to the program and try to run this method and see what happens. So here the program giving me output as 120, which is expected. Now let's say this base condition is not there at all in your program, in any of the recursion algorithm, right? So what will happen in that case? A stack overflow error happens, because if this calls goes on like this and it never ends, then what happens? It utilizes all these things, right? Method calls and variables. It keeps on stack. So there is a limit on the stack memory, and if it crosses that limit, you will get stack overflow error and you will never come out of that particular error. You cannot handle it using the exception handling. So this is one more thing we need to see, that we should have always a base condition. I hope this is clear. So this example is there in my GitHub link. You can go and download it. Thanks for watching this video and stay tuned.